Here we want to use the Euclidean algorithm to find the GCD, which is also called the greatest common divisor. We're going to look at the numbers 20 and 55. Okay, now the Euclidean algorithm states the following. If we let a and b be any two natural numbers, like 20 and 55, where a is greater than or equal to b, 55 is greater than 20, we're going to divide a by b to get a remainder r. If r is equal to 0, then we would say the value of b is the greatest common divisor. But if r is greater than 0, then we need to continue dividing by b by r to get a remainder s. And if s is equal to 0, then we would say that r is the greatest common divisor. But if s is greater than 0, then we do the division again. So we're going to divide r by s to get a remainder of t. We're going to continue the division with remainder process until a remainder of 0 results. And then the last non-zero remainder is called the greatest common divisor. So let's take a look at the first step here. The first step is we're going to take the value of 20, and then we're going to divide that into 55. Okay, 20 goes into 55 two times. 2 times 20 is going to give us 40. So when we subtract, we get 15. Okay, now because we get a remainder that is greater than 0, it's not equal to 0, now we're going to continue to the next step. So now we're going to use the remainder here, 15, and now we're going to divide that into the divisor of 20. Now how many times is 15 going to 20? Well, the answer is once. 1 times 15 is 15. If we subtract, we get a remainder of 5. Now again, because we don't get a remainder of 0, we're going to have to continue the same procedure. So therefore, we get the third step. We're going to take the remainder of 5, and then we're going to divide it into 15. Now 5 goes into 15 how many times? 3, because 3 times 5 gives us 15, and when we subtract, we get the amount of 0. So therefore, because we got a remainder of 0, then we're going to use this number here, 5, as the greatest common divisor. So let's go ahead and put our answer in. We put in 5 here, and there is our result.